Hi. Okay, so what we're doing today is working on our proportionality with triangles and seeing if they're similar. If they are similar, we're going to give them a congruency statement. So just like when we were determining whether we had congruent triangles, we looked at corresponding congruent angles and then the corresponding congruent sides. Okay, so this time we're going to look at corresponding congruent angles, but the side lengths are going to be proportional. And that's how we determine whether they're similar. Because remember, they're not the same size. They're the same shape, but not the same size in similarity. And then if we do find that they are similar, we will state how they're similar. Either by angle-angle similarity, side-angle-side similarity, or side-side-side similarity, or side-angle-side similarity. And then we write the similarity statement, which is like triangle EGF is similar to triangle RST by side-angle-side. Okay, so that's the similarity statement, but let's look at what is going on in this triangle. These two triangles. Okay, so here we have a smaller triangle and a larger triangle. So what we're going to do is we notice that there is an angle that's marked. Angle F is congruent to angle T. And then we have this side, the angle, and this side to this side, the angle, and that side. So when setting up our similarity statement, order matters. So we have to figure out which sides would be corresponding to each other. Okay, so the rule of thumb is just go with the smallest side here to the smallest side here. So I see the smallest side here is 3. So I'm going to put a 3 over the smallest side on this triangle is 9. Those are the sides that should be proportional. So I've got 3 over 9, and then the question mark. Is it equal to bigger side here, 5 over 15. So is 3 over 9 equal to 5 over 15? Couple of ways I can do this. I can cross multiply 3 times 15, which is 45. And does that equal 9 times 5, which is 45? Yes, it does. So cross multiplying is one way to do it. The other way is to reduce. 3 goes into itself once, 3 goes into 9 3 times. And then again, reduce this. 5 goes into itself once, 5 goes into 15 3 times. So I have my scale factor, 1 over 3. So this triangle is 3 times larger than this. That's what we mean by 1 to 3. Now to set up my similarity statement, I identify my congruent angles and my proportional sides. So EF is similar in proportion to RT. So when we write that, that's what we mean, that this side is proportional to this side. Then I'm setting it up as a side angle side. Put that little other S here, so I got a side angle side. So I bring in the angle. Angle F is congruent to angle T, and that was given information. These were already marked. And then I look at line GF, which is similar to line ST. And notice I'm going in the same direction. Here's my marked angle. I started with the outside from that and brought it in. So I did that here, and I do the same thing here. Order. We just want to make these as orderly as possible so that when we're looking back at them, if somebody else is looking at them, they can clearly understand what's being said. Alright, so I've established that we have similarity here. I've established which parts of the two triangles I'm talking about. So the next thing I'm going to do is write my similarity statement. Now, easy to write the first one. I can just pick letters. EGF. So triangle EGF is similar, but now when I go to the second one, I have to make sure I match up my angles. So angle E is right here. The angle that is congruent to angle E is angle R. Then I go to angle G. The angle in this triangle that is congruent to angle G would be angle S. Then I go to F right here. So I went E, G, F. And I'm going to do the same here. R, S, T. So I've got to follow the same order here that I follow here. So a triangle EGF is similar to triangle RST by side, angle, side. And the side, angle, side there. Okay, let's take a look at this one. 3 sides are given. 3 sides are given over here. So we just set it up with looking at this one. Where's my smallest side? There's a 22, 28, and 35. 22 is the smallest. That 22 over. And now when we're doing 3 sides, it's important to keep with this triangle I started with, the 22. That's on this triangle. So everything up here is from this triangle. Everything down here is the corresponding part from this triangle. So smallest side here is 22. Smallest side here is 16. So 22 over 16. Does it equal? That's why I put the question mark. Next side up, 28. Does it equal 28 over 20? Then I look at the next part. Biggest side here, 35. Biggest side here is 25. So again, is this proportionality the same as this one, 35 over 25? So when I reduce these, I pulled a 2 out of this. 2 out of 22 leaves us with 11. 2 out of 16 leaves us with 8. And then on this one, we pulled out a 4. 4 from this leaves us with 7. 4 from this, a 5. Okay, those two don't match, but just out of curiosity. And I'll tell you, when you get to these two, if they're different, you're pretty much done. It's not similar because all 3 of these have to be the same. But we're going to go on just for the sake of finishing it off and making it look nice and neat. So when I reduce this, 5 goes into that 7 times 5 goes into that 5. I get the same 7 over 5 for these two, but they don't match this one. All 3 must match. Not similar. On this triangle shape, so I've got my 2 triangles. All right, you can see this was given information 42. These are vertical angles. When I see this is 42, I immediately mark that as 42. So now I have 2 corresponding congruent angles in the 2 different triangles. And then I look and I was given 53. And I was given an 85. So basically, this is 42 and that's 42. These other 2 angles have to be the same here and here. So, what did we do here? We added 42 plus 53. And that came to 95. Then we took 180 minus 95. And that comes to 10 minus 5 is 5. That is a 7 minus 85. So that means this angle had to be 85. Now when I look over here, I can see I have the 42, 42, the 85, the 85. There's no option. This has to be 53. Because 42 and 85 add something to it to get to 180. It's got to be 53. So I don't even really need to do this one. If I'm doing this, it's because I don't really get this concept of this closed kind of figure here where it can only add up to 180, so there's limited numbers that it could be. And if this one's 42, that's 53, and I already know this is 42, and I have an 85, and there's my 85, that has to be a 53. So I really don't need to do this one. I could see it from this. And then I see that I have the triangle congruency by angle, angle. Then it's a matter of setting up the correct order. A, B, E. A, B, E, that triangle is congruent to 53 is here, 53 is here. D, then we went to B, the 42, and then C. D, B, C, triangle. Oh, that should have a triangle in front of it. There we go. And that's by angle, angle similarity. So I write that. Okay, next, I want to go to this one. Now, these are always tricky. So I kind of outlined in bold letters and colors the trick to it. I have the original picture here, which I hopefully you have in front of you, is this small triangle embedded into a larger triangle. So this isn't that, it's not difficult. We can see we have the smaller triangle and the larger one. But what is tricky, what we just have to constantly remind ourselves of, is that the bigger one is from here to here. So we use the 18 on the smaller red triangle. We use the 15 on the smaller red triangle for those sides. But the bigger triangle is not going to be just 6. It has to be 6 plus 18. And this is not going to be 5 because these numbers do not give us a triangle. They give us a trapezoid, 4-sided figure. So we start the smallest side on this triangle, which is a 12, over the smallest side on this one, which is a 16. Now I went ahead and added these up so that I wouldn't forget what their numbers were. So that's how I knew which side was going to be the smallest. So I have 12 over 16, this over this, is equal to, and I got to set all 3 of them up, 15, this side, over the whole thing, 20, which is equal to, and these proportions all have to come out the same, which is equal to 18, this smaller side here, over 6 plus 18, 24. 18 over 24. Okay, so now I look at each one of these and I reduce. 4 goes into that 3 times, 4 goes into that 4 times. This reduces to 3 over 4. 5 goes into that 3 times, 5 goes into that 4 times. Reduces again to 3 over 4. I look at the 18 over 24. 6 goes into that 3 times, 6 goes into that 4 times. So I can see there's a consistency with the proportionality in the ratios. So therefore, triangle. Now I got to line it up correctly. X, P, Y is similar to triangle Q, P, R by side, side, side. I compared all 3 sides, so that makes it a side, side, side. Okay, that's the last I'm going to do on this one. I'm going to give you a different video for the next one because this is getting too long already. I hope that's helping.